Hey, welcome back to your favorite intermediate algebra class. Good to see you today. We're going to talk today about graphing and solving systems of linear equations, including like this first example, checking whether you have a solution of a system of linear equations. So first of all, system of linear equations means you got two or more equations. Okay, and they got to be of the form, y equals mx plus b, or the standard form, ax plus by equals c, where a, b, and c are real numbers there. So you got a couple of linear equations here in this first example. 3x minus y equals 1, x plus y equals 3. So we got this system. So we're checking, first of all, is -1, -4 really a solution? And again, a solution to a system means it has to satisfy both of those equations. So all I have to do is plug it into each of them and see if and if they're both true, it's a solution. If one of them is false or both of them is false, then I obviously will say that point is not a solution. So let's plug in this xy initially into the first one. 3 times -1 minus the -4. Does that equal 1? Yeah, and you're like, okay, so far so good, right? Let's plug it into the other one now. So we got x plus y equals 3. Now we plug in the -1 plus the -4. Does this equal 3? No, -5 does not equal 3. False. So what we say is -1, -4 is not a solution to this system. Okay? Not a solution. Let's go back up. Now let's check the 1, 2. 1, 2. Let's see if that one is a solution. 3x minus y equals 1. Throw in x and y. You got, oh, that works. True. All right. Now we plug it into the other one. X plus y equals 3. 1 plus 2 equals 3. Hey, that works. So true. So since it's true and true, that's what we have to have. It has to satisfy both equations. 1, 2 is a solution to this system of equations. Okay, so again, if you get one of them to be false or both of them to be false, it's not a solution. So graphically speaking, solutions to a linear system are going to be, if you got two of them, it's going to be one of these three situations. You have where the two lines cross, and right at that point, that xy value, that's your solution. So you have exactly one solution. Another term for this you may see on a comprehensive final, oftentimes thrown out, is consistent, meaning I have a solution. Independent, meaning I only have one. That one point, that one xy point, that is independent of all the other points, and it's the only one that works. Okay. Now, this one, you're looking at this, you're like, wait, I only see one line. Well, there's one line here, and the other one is right on top of it. Okay, so how many points do they intersect at? And you're like, oh, it's got all these points, right? How many points do they intersect at? And you say infinitely many points. So infinitely many solutions, or it's referred to as consistent, again, meaning I have an answer, dependent, and it's all those answers. So infinitely many, okay? Infinitely many solutions there. Now, the last one here, can you see how the two lines are parallel? And you say, well, how many places do they cross? Well, they don't cross because they're parallel. So we say no solution, or inconsistent, meaning I don't have a solution, okay? So again, to review that, you have either one, infinitely many, or no solutions depending on the two lines you got. So let's solve this system by graphing. -2x plus y equals 5 and x plus 3y equals 8. So we're going to approach this by solving for y, first of all. So let's put it in y equals mx plus b form and graph this thing. Let's see what it looks like. Y equals 2x plus 5. So my y-intercept is 5. I start there. 1, 2, 3, 4, 5, right there. And my slope, my rise over run, is 2, or 2 over 1. So I could go up 2, right 1, up, 2, right, right, 1. Or I could also go, this is the same thing, I could also go down to left 1 if I wanted to. From that point down to left 1, you notice it's on that same graph there. Okay, so draw that best I can. Ugh. Alright. Alright, let's graph the other one now. X plus 3y equals 8. Erase this for a minute. X plus 3y equals 8. Solve for y here. Divide by 3, each of these. Y equals negative 1/3 x plus 8/3. Now this is kind of annoying. Our y-intercept is 8/3, or in other words, 2 and 2/3. Same thing, 8 divided by 3 is 2 with remainder 2. 2 and 2/3. 2, 1, 2, and 2/3 of the way up, so I'm like right there kind of deal. 2 and 2/3. And then I'm going down 1, right 3. Down 1, right 3. 1, 2, 3. So I'm right there. Okay? And then I draw that line as best I can. Now, here's the thing about not doing this on, ideally this would be on graph paper with a ruler kind of deal. And I'm looking at this and I'm like, well, it looks like I have one solution. It looks like they meet right there. I am proposing that this point, negative 1, oops, negative 1, 3, appears, this appears to be my solution. And then I'd go ahead and I'd plug it into both points and just double check, right? Because this is graphical. It's kind of hard to see. I plug it into negative 2x plus y equals 5. I say, yeah, 2 plus 3, 5 equals 5. Hey, that one worked out. Let's plug it into the other one. X plus 3y, x plus 3y, is that equal 8? Negative 1 plus 9. Hey, that one works out too. What do you know? Negative 1, 3 really is where those two cross. Okay, but again, do this on graph paper, a little easier to see. Tell how many solutions this linear system has. X minus 3y equals 1. So let's take this one, x minus 3y equals negative 1. Let's solve that for y. Okay, so I got that one. Let's go ahead and look at this. What would this other one be? Looking at these thinking, oh, these are kind of similar here. Divide by negative 3. Got 1/3 x, but this time positive over negative, minus 1/3. Okay, so this green one has a y-intercept of 1/3, and then it's up 1, right 3. Okay, so it's got the slope of 1/3, and you notice this red one is down 1/3 as your y-intercept, and then it's up 1 and right 3. So they both have this same slope, right? But different y-intercepts. So they're different lines, same slope. You know these things are parallel. So you say, oh, well, there's no solution. Okay, so if you end up with parallel lines, not the exact same line, but parallel lines, you can say, hey, no solution, they never cross. I don't have an answer there. How many solutions does this one have? So we got this negative x minus 3y equals negative 1. We're going to solve that for y. Oops. Negative 3y. Divide by the negative 3 here. Each of these, negative 1/3 x plus 1/3. Okay, there's that one. Let's go do this. 3x plus 9y equals 3. Divide by 9. So we got negative 1/3 x plus 1/3 when we simplify that. Now I look at those two, I'm like, wait a minute. That one, same as that one. They are the exact same line, right? If I was to graph those things, I'd be up 1/3. I'd go down 1, right 3. Put the dot, there's my black one. I'd do the green one, I'm up 1/3, down 1, right 3. Put that one on there, oh my gosh, same line. What do you write? Well, how many points do they cross at? Infinitely many. So this is infinitely many solutions. That's our answer, same one. Okay, so just to recap, you either have one solution, that's where they cross, you'll see them cross on the graph, infinitely many, they're the exact same line, or referred to as consistent dependent, and finally known solution, which is inconsistent. See you guys in class.